This is Team RuneScape. We are with Software Engineering 2 with Professor Hughes at Grand Canyon University. This is our CLC Milestone 2 for our weather station, and we're going to be having James take us away with going over our functional, non-functional, and technical specifications.
My name is James Stone, and I was in charge of our functional, non-functional requirements and our technical specifications. Like the obvious first thing that goes into our functional requirements for a temperature and humidity detector is a temperature and humidity sensor, which is primarily the DHT11 module. The second thing we the second thing where I'm planning on adding is like a data storage for, the amounts of reading when you want to look back at it, which will probably require a SD card. Further down the line, we are planning on adding multiple sensor modules, but those will be added at a later date. Our next thing is non-functional requirements. Like one of them is obvious. We must have a certain accuracy to detecting temperature and humidity and sensor data uploading every 5 seconds. We also have a non-functional requirement of it connecting to Bluetooth for a certain distance. And the final technical thing we'll go over is like a technical specification. Like we're planning on having it be weighed down so that it doesn't lower in the wind. Well, it'll be a mechanical pull through, but we're planning on adding something weighted, maybe steel or something a little less than 1.5 kilograms. I think that's all I like to say about this topic. Moving on to you, Maverick.
All right, thanks, James.
Mhm.
So after we developed our functional, non-functional, and technical specifications, we were able to come up with our UML to help outline, excuse me, not our UML. Our UML, yes, but our flow chart. And from our flow chart, it kind of gave us a high level overview of what we envision this project to be. So the project will power on, it'll initialize all of our sensors, it'll run through the loop, it'll read the environmental data, log the data, and it'll finally go to a decision if it needs to take a picture. Part of our sensors is to capture the data for sunrise, sunset. So we're getting creative. I'm going to be using a photo resistor module to track the light, the sun, and capture an image. From that, we were able to develop our UML, kind of our pseudocode structure of how we're going to structure our Git. So for each sensor, we had our attributes, a couple methods here and there. We're still building it out, but we're going to have our DHTC sensor class, camera module class, photoresistor class, our data logger object, and our weather station controller. With that, I'm going to turn it over to Ron to talk about our Git and our structure of our code base.
All right, so we have completely organized our project in order to have it components for each sensor. So the DHT11, the light sensor, and so forth get their own subcomponent. At the same time, we have subcomponents for configuration and network management functionality in order to keep the complexity of that outside of the main application. Then the main application itself has multiple C files whose only job it is to integrate these subcomponents. So the main, of course, handles our events, initializes everything. Network is responsible for configuring the network based on information loaded from the configuration. And sensors unifies all of the sensor inputs into a format that is coherent for proper logging and transmission if needed. Each subcomponent, of course, has its own header file, C files, and everything. So that way it can stand on its own and potentially be reused in future projects. And we have, of course, made sure that all of this is properly committed into the repository in order to make sure our progress is accurate and tracked, and in order to ensure that everything doesn't get out of sync and we don't end up working on different versions of the code base. Doing this planning upfront ultimately saves us time because we will encounter these design decisions later, and putting them off makes them a lot harder to create a coherent program.
Awesome. Thank you, Ron. Thank you, James. And thank you, Professor Hughes, and everybody else who took the time to watch our video. I hope you guys enjoyed, and we'll see you guys in the next one. Thank you.